My name is Taylor. I'm an applications engineer with onsemi. I'm joined with my coworker Brandon today, and we're here to give you a demonstration on the RSL15 Ultra-low power mode and Smartsense Wake Up. So hello, Brandon. Thanks for joining me.
Thanks for having me, Taylor.
You have been able to help me put together some software to make a demo here because you are definitely better at it than I am and could do this a lot quicker. What we wanted to show today, right, the main value really in our Bluetooth microcontroller is our ultra-low power. We are the lowest power consumption on the market, where we're going down to as low as possibly, about 70 nanoamps versus we go up to like 10 milliamps depending on how much our transmit power, right? So I tried starting out with just one of our sleep demo sample code. It works fine. I was able to set it up for ADC threshold wake up, but it doesn't properly show our low power and then also our higher power consumption by actually doing anything. So you were able to help me put this demo together. We have one of our RSL15 boards, and we've just hooked up a photo transistor to one of our analog inputs. Down in the right here, you can just see the voltage I'm also measuring with my little Shaley device. And up on top, we are measuring the current consumption. So what we see is when nothing is going on, the power consumption is going down to the lowest state. So because we just have our sensor plugged in and some other different things, it's sitting up at about 13 microamps. But if we actually go ahead and say just disconnect my logic analyzer and the sensor, we see, oh yeah, there it really drops down. And look at that. We have about 260 nanoamps. That's about what you were expecting, right, Brandon?
Yep, that's about what's in the data sheet.
Okay, so that's really cool to see. But then if we hook it back up, we can see how this actually does something. Right, so one of our different wake up options is ADC threshold, right, with Smartsense. Mm-hmm. So you were able to set a voltage, and when that pin goes above or below it, it's going to cause a wake up event.
Yeah, that's the idea. We save the state so that when you go above the threshold, it'll turn the LED off. And when you drop below the threshold, it'll turn the LED back on.
So then getting into how we made it a bit more interesting, yeah, it's not just waking up, it's also sending an advertising packet. And you set up this guy to listen for that. And depending on what message it receives, it's going to turn an LED on and off.
Yeah, that's the idea. When the device wakes up, it'll actually read the state in which it woke up, either raising above the threshold or dropping below it. And it will load that information into the advertising packet, which the central device, which is scanning for that packet, will see. It will parse the state out of and then adjust the LED accordingly.
So then these devices don't have to be paired either, right?
No, in this setup, it's just simply advertising, and the scanner is looking for that advertising packet.
Okay. In that case, actually, we can set up multiple devices that could listen to that advertising packet pretty easily.
That's the idea. Right now, it's set up on the central side, so it's only looking for one specific address, the accept list, but you can expand that accept list to include other addresses for additional devices if you want to add more sensors to it.
So here I have the Murata version of our RSL15. This is the system in package. And I've just put the exact same code you made for this guy. I put it on over here. And now it's actually going to do the same thing. And it's going to listen for that wake up, go on and off. So that's pretty cool. Obviously we're just turning on the little LED here, but you could think of this as maybe like a little battery powered sensor for outdoor lighting. They're both operating off the battery, but it's really, this guy has been programmed to have that super low 260 nanoamps we just saw. And if we compare this to our transmit power, so this is one of your advertising data packets. And it's running up at about 4 milliamps. If we turned up the power, the TX power strength, it would probably go up to maybe 10 milliamps.
Right.
Let's take a look. So what is actually happening? So right now it's asleep. I'm going to cover the light and it turns on. We see a bunch of different little bits of activity here. So what exactly are all these different ones you have in the code?
Yeah, so each spike you see there is an advertisement containing that state data. The way advertising works in Bluetooth Low Energy is that it sends it over 3 channels. So right now it's configured to send about 10 of these bursts just to give the central the best chance of actually scanning it. Because as central is scanning, it will also be hopping across channels. And we have to hope that when the advertising device here sends this burst, that the central is also scanning on the same channel. So by adjusting the size of this burst, you can increase the reliability to see the package, but we found 10 offered good reliability in this test.
Okay, and that makes sense, right? Because there's no bidirectional communication here. Your peripheral side isn't waiting for confirmation from the central. So it just wants to send out a bunch of different bursts and best hope that it hears it.
Right. In this case, it's more of a broadcast protocol where the central's just waiting to see that message.
I guess what are some different steps, right? So this wouldn't have really any kind of secure element to it. It'd be pretty easy to just spoof whatever this guy's doing and send your own commands. Tell it it's day, night, day, night, day, night.
Yeah, in this situation, there's no encryption or any protections like that. It's simply throwing it out in the air, unencrypted entirely, and seeing who listens. It'd be easy enough to sniff this and reproduce it.
Okay, but do you think we could do something to make it secure? Are there any options?
Oh, yeah, absolutely. At the cost of more power, you could definitely have central negotiated connection with the peripheral when this all starts. And in the case where you want extra security, you could add some sort of pairing with authentication. That would mean on the peripheral side, you either need to do some out of bounds pairing, which means using something like NFC to communicate a secret key between your central and peripheral when you turn them on, or something like passkey entry, where you might have a code on the box for the product that you have to enter into both devices to make sure that only devices that have that code entered can actually talk to one another. But in that case, you could actually use the pairing to go as far as encrypt the entire communication for the on-off messages so nothing can sniff it out of the air without access for that specific key.
Oh, okay, so there's definitely some options there. Like, yeah, you might lose that nice little latency of how quick and easy this is, just sending an advertising packet. But yeah, if you need to have the security, adding in the negotiating back and forth and having that pairing figured out is definitely possible.
Oh, absolutely. It'll be a balance between how many security features you want and how much power you consume, because you will see the device staying awake longer to do those negotiations and to establish that security.
Yeah, and the best way to consume power is to just spend as much time as you can asleep.
Yeah, no, for this device, the more time you spend awake, the more power lost. The sleep mode is definitely what keeps the battery alive the longest.
Okay, and that's all for today's video. Thanks again to Brandon for helping me put together the firmware in this demo. If you want to learn more about it, you can check out community.onsemi.com, where he has put together a knowledge base article going more in depth into the firmware sample he created here. While you're there, you can also check out our battery life estimator, where you can calculate the amount of energy being consumed by our advertising packets and our sleep states, and calculate the expected battery life of your given battery size. And as always, check back soon for another video.